Tantalisingly, the only record of a live giant squid in the deep is this series of murky pictures taken 1,000 metres down. It appears to thrash its arms about. The only video is this brief glimpse looking down from a ship as the giant squid breaks the surface. It seems to jet water as it tries to escape. But these images reveal very little about their behaviour. To understand how these elusive creatures live and hunt and replicate, we'll carry out a dissection. We'll also look at their more accessible living relatives, the octopus and other kinds of squid.
It looks beautiful.
First impressions when you look at a squid like this is it looks like a complete and utter alien. It's quite good to get your head round exactly what the major component parts of them. So if we start at the back, you've got a tail fin here. All this is a mantle. Inside here is digestive system, reproductive system and so on. Then you move forward, you've got the funnel which is involved in propulsion and locomotion. You've got eyes here, there's one of them on that side. If we pull this arm back, you can see essentially the mouth and the beak in here. And then at the front, the bit that squid are most famous for is all these arms, 8 arms at the front, but then the tentacles, which are just way, way, way longer than the arms. Guys, do you want to... I've got a digital microscope here, a little toy. Do you want to see?
Look at it on an arm.
That's great. So just, Steve, just talk us through, what are these black specks that we're seeing here on the microscope?
What you're looking at there are the chromatophores, and each one of those it's a sac that's controlled by muscles. And by opening and closing, or contracting and relaxing these muscles, it can increase or decrease the size of the sac, the pigment that you've got in there.
Okay, but then it can change that...
Just like that.
Instantly?
Instantly.
We don't know how giant squid use their chromatophores, but we can get an idea of these smaller, freshly caught squid. They can create sophisticated patterns of colour. You can see in this one, it's spreading up and down the body. It even seems to respond to my touch. In spite of the fact that this squid died a few hours ago, these muscles are still clenching and relaxing. It's oddly beautiful, actually.
If camouflage fails, as in this battle with a moray eel, after squirting ink, the next survival tactic is a jet-propelled escape. To power this flight, they need to pump a lot of oxygen into the blood. Perhaps this is why squid have 3 hearts.
This makes me nervous. I'm wondering whether that structure that we have there is the 3rd heart.
I'm surprised that would be a heart. It doesn't even look like muscle.
No, that is amazing. That's just
like gloop.
Incredibly thin-walled. Joy's injecting ink to hunt for the 3 hearts, but even for the experts, finding them is proving difficult.
Oh, where are we going?
It looks like there's a connection maybe right there. Can we break this? Oh, look. There's the connection. I just let it drain in from here, and it's now filled this. So this must be that chamber, that heart chamber.
So that's actually, that's not the heart.
That's still the vessel coming in.
A vessel, and that there is the heart.
Oh, okay. So that's the heart pumping that, pumping into here, and this is the heart pumping into this sac that's right over here.
Okay, so we've got here, this is the central systemic heart, the big one if you like. That's the pumping blood out to the whole of the body. The body's taking oxygen out of the blood, carbon dioxide's going back into the blood, it's then coming back to the branchial heart. So that pumps it through the gills, where the carbon dioxide goes out into the water. Oxygen's picked up from the water into that blood, which then comes back and then drains through these big vessels back to the systemic heart, so it can then pump oxygen-rich blood back out to the body.
You've nailed it.
Beautiful.